Welcome to Teletype Talk, episode number 6. I'm your host, Joe. I think we've got a really fun episode in store for you here today. We're going to do quite a few different things. You can see here on the Teletype, we've got a single pattern in use. And what I want you to notice about that pattern is that it's driving a full drum kit, a 7-piece drum kit actually, over here on the ER301. It's also driving the individual trigger ports here on the Teletype, and as well as the trigger ports on the Ansible. I'm not really using those, but that's just to kind of show you that you could, use it with other modules as well. What I want you to notice about this, though, even though there's only one pattern in use, it's driving the entire drum kit over here. And, sometimes it's hitting an individual piece, like the kick drum. Sometimes it's hitting multiple pieces together. So we've got kind of a secret code going on over here to allow us to do that with just a single pattern. And so that's one of the things we're going to talk about today, is using the bitwise operators to do some encoding of our data. I'll let you take a listen to what this sounds like. We're also going to build this grid ops controller. So this grid ops controller allows me to change my patterns on the fly and even store and recall some patterns, kind of copying them back and forth from different memory locations. So for example, here are my kit pieces in this highlighted row. Right now I'm on the kick drum here. If I switch to the snare, you'll see that it shows me where the snare hits are in this pattern. This one's the hi-hat, so it's on every beat. So if I want to change this, I can just do it in real time. I've got some stored patterns here in these other presets. So what I can actually do is copy things back and forth. So if I want to copy whatever's in memory location 3 into memory location 1, and memory location 1 is the one that's always playing, I can do that in real time. And let me just demonstrate here. So what I'm going to do is hold down memory location 3 and then press button 1 and we'll hear it switch. So I think that's about it. We're going to go over the bitwise operators and how to set something like this up, and we're going to build this really cool grid ops controller to control the whole thing, program our beats, and also kind of manipulate them in real time. So we're going to take a trip over to the computer and do just a really quick crash course in binary. In case you don't have any experience with it, we'll get you familiar with it enough to be able to use it, and then we'll come back here and build this scene. Okay, so this is going to be a quick and dirty talk on how to make a binary work for you. This is not going to be a math lesson. I don't even know if I'm going to use the proper terminology here. I'm just going to basically tell you enough to help you put some binary to work for you on your Teletype, and kind of also show you how to use this Google Sheet that I am going to share with you. So in a nutshell, binary, the numbers, you can represent the same number in decimal that you can represent in binary, but they just look a little different because in decimal, we're using base 10, so we're allowed to use the numbers 0 through 9. In binary, we're using base 2, so we're only allowed to use the numbers 0 and 1. So if we start here with a 0, it's got a decimal value of 0, and its binary value looks like this. I think I've got this going out to 16 digits. And we count just like we would in decimal. So if we increment this to 1, you can see over here The binary value is, a bunch of zeros and then a 1 at the end. And its decimal value is also 1. If we were going to count in decimal, we would move this up to a 2. But we're not allowed to do that in binary. It's just base 2. So just like when we get to the number 9 in decimal, what we would do here is zero this out and make this next number over here to the left a 1, and we'd get 10. In binary, since we're already out of numbers, what we'll do is make this a 0, and we'll flip this next bit over to a 1. So kind of looks like 10 in decimal, and here's what it looks like in binary. A bunch of zeros and then 1 0. But its decimal value is actually 2 here. And if you look across the top here, we've got 1, 2, 4, 8, 16, 32, etc. They just kind of double as we go along. So, here we've got 2 times a 1. 2 times 1 is 2, plus 1 times 0 is 0, so we just end up with 2. If we were to keep counting, we'll just do 1 or 2 more here. The next thing I would do is increment this column on the right. We get a bunch of zeros and then 1, 1. The decimal equivalent is 3. 2 times 1 plus 1 times 1 gives us a 3. Again, here we've kind of maxed out on these 2 bits. So what we would do is increment the next column and 0 these out. We get over here a bunch of zeros and then 1, 0, 0. And the decimal value is 4. 4 times 1 plus 2 times 0 plus 1 times 0. So you can see it's pretty simple. It's just another way of counting. It's really kind of the way computers count. So why is this useful to us with the teletype? Well, the teletype has some operators that allow us to get and set the different bits of these binary values. You'll actually see them represented in the teletype in their decimal equivalent, but we can manipulate these bits individually, turn them on and off. So let's imagine that this is a step sequencer right here, right? We've got steps, 1, 2, 3, 4, 5, 6, 7, 8, etc. Let's say that across the top here, we wanted these bits to represent different voices that we want to trigger. So for example, maybe this is a kick, maybe this is a snare, maybe this is a hi-hat, maybe this is a crash cymbal, and so on and so forth. So if I had, let's say an 8-step pattern here, 1, 2, 3, 4, 5, 6, 7, 8, and I wanted the hi-hat to trigger on every single step, I could fill these with 1s. So we'd get the number 4. So what if at the same time as the hi-hat on the first step, I want the kick to trigger? I could put a 1 here. This number changes to a 5. And what if on the 5th step, I wanted the snare to fire? I could put a 1 in here, and that becomes a 6. So you can see we've got these decimal values that we could stick into a pattern, but using the teletype, we'd be able to extract out the individual bits here and figure out which kit pieces we want to trigger. So hopefully that makes sense. I won't be using the spreadsheet, although, like I said, I'm going to share it with you, and you can use it. You could actually, when we're done, just figure out which pieces you want to hit with this spreadsheet. Come in here, kind of put the 1s in the right places, and go and put the decimal values here straight into the patterns. All right, cool. Let's go back to the teletype.
Okay, now that we understand a little bit about how binary works and how to count in binary, let's take a look at some of the bitwise operators on the teletype. So to get started, I'm just going to take one of my variables here. I'm going to take A and 0 it out. And what I want to be able to do is to be able to get and set individual bits of these numbers. So they're going to be represented on the teletype screen in decimal, but we're going to treat them as though they were binary. So let's take A and set its value to A, but let's set a bit. So we'll set a bit of this number that's stored in A, and we'll set the first bit, or the least significant bit, and it's actually numbered 0 in the teletype. We start with 0. So let's set A to that. What do you think it's going to be? If you think it's going to be a 1, you are correct. So let's go ahead and set the second least significant bit, numbered 1. And that value is going to have a value of decimal 2. So it's going to add that to what's already there. The least significant bit is already set. And so we get a 3. And we can also read these bits. So let's go ahead and do bget. And we'll choose A. And let's take a look at the least significant bit, numbered 0. And it comes back as a 1. And if we take a look at the second least significant bit, it also comes back as a 1. So what do you think we'll get if we look at this bit? Yep, it comes back as a 0. And then one other command we want to take a look at is the clear command. So let's do A, be clear, and we'll use the value of A. And let's clear that least significant bit. And you can see it comes back as a 2. So you can see we can kind of unmask these decimal numbers and get their individual binary components out of them, and that's going to be useful to us. So let's go ahead and start to create our script. I'm going to set metro to something fairly moderate, but we'll just use kind of the 16th note values. So let's set metro equal to BPM 90 divided by 4. And let's pop over to the metro script. And in here, let's just go ahead and do a pattern.next. And let's actually go over to our pattern. There's nothing set up in here yet. And let me go ahead and go down to the 16th step. And I'll do a Shift E and a Shift L to set the loop point. So now we can see that our pattern is advancing through 16 steps and then coming back to 0. All good stuff. We've done this before. So now what I want to do is actually read the values that we have stored in this pattern and use this binary decoding on them. So let's go ahead and call another script, but let's do it in a loop. We're going to do it, I've got 7 kit pieces set up over here. You could do more or less if you want, but I'm just going to go ahead and do it for 7. So let's set up a loop to call another script. And script 1 is our first unused script. So let's use that. So now every metro tick, I'm going to go ahead and call script 1 7 times. And let's go ahead and let's use a global variable for this. And we're just going to set x, and we're going to do a bget. And we're going to take a look at our pattern. And the slot we want to look at is whatever the pattern index is set to. So 0 through 15 in this case. And what we want to do is get the bit that corresponds to I. Remember, I is our loop counter. Now there's nothing in the pattern yet, so let me go ahead over here and let's just set up a couple of values. Let's set this to a 1, which would be the kick drum by itself. And let's set the next one to a 2, which would be a snare by itself. And let's set this one to a 4, which would be a hi-hat by itself. The next thing I want to do is do an if. So this x should come back and be either a 0 or a 1. So I can just do if x. So if x is a 1, we want to go ahead and send our trigger to the appropriate place. For me, it's running on the ER301 sound computer, so I'll do sound computer trigger pulse. And let's see, what do we want to set this to? We want to trigger the port that's equal to I, but actually these are I is 0 through 6. On the ER301, they're numbered 1 through 7, so I want to add 1 to it. So we can just add 1 to I. Great. Mute that for a sec. Also, if you're not using a sound computer, let's just do another statement here to include the standard trigger ports. So we'll do if x, tr, pulse, and again, we'll just add 1 to I. So we're firing these ports here. So you could do up to 4 ports kind of natively on the teletype itself, 4 triggers. You could go ahead and do up to 8 if you have an Ansible connected over the I2C bus. And if you wanted to use a TXO, you could do that. You just have to put maybe an additional condition in here. You could also use these CV ports as triggers like we talked about back in, I think, episode 1. So that seems to be working. Let's see if we can get the kick and the hi-hat to fire at the same time. So I'll pop over here to my pattern, and on this one, let's see, the kick is trigger 1, the hi-hat is 4, so let's put a 5 in here. Sounds like it's working perfectly. Piece of cake, huh? Okay, so the next thing I want to do is start to build out this grid ops controller. So if you'll recall, we had a row on the grid ops controller that was just kind of flashing a light at the pattern index that we were at to give us kind of a sense of where we're at in time. So let's go ahead and do that. I'm going to come back over to the Metro script. And what I want to do here is light up some LEDs, and I want to do those in the second row. So let's insert a new line here before we do a P next. And let's do g.led, that's grid LED. And we're going to give it an x coordinate of the pattern index, which is going to be 0 through 15. And we're going to give it a y of 1, which would be the second row. They're numbered 0 through 7. And let's just set that LED value to a 0. So basically, we're going to unlight the light for the current step. And let's insert a new row here after we do the P next. And we'll do g.led. And again, pattern index for the x value. It's incremented now. And y at a fixed value of 1. And let's set the brightness to 10. So if I come back over to my live command screen and hit Alt-G, we can see a representation of the grid. And we've got this happening here. The next thing I want to do is throw some actual buttons onto the grid. So we haven't done that yet. Right now we're just kind of playing with some lights. So let's go ahead and do those in the init script. And that way these buttons come to life whenever I load the script. And we're going to use here the kind of the granddaddy of all the button creators, the g.gbx operator. This creates multiple buttons in a group. So we're going to be using this group feature here in a bit. So let's go ahead and start off with group number 1. And we can start off with the ID of number 1. We're going to put this at coordinates x0, y0. And these buttons are just going to be 1 wide by 1 high. And we're going to make these type 1 buttons. So these are latching buttons, the kind that stick when you press them. We'll give them a default brightness of 2 so that we can kind of see them on the display. We're going to have them call script 2. And we want to create 16 columns of these buttons and 1 row. Since these buttons are going to interact with the other buttons, let's go ahead and put the other set on there. So we'll do another g.gbx. This is going to be group number 2. I'm going to start their ID at 17 since we've already started with ID 1 here and created 16 buttons. That takes up the first 16 IDs. We'll start with 17. I'm going to put this at x coordinate 0 and y coordinate 4, so it'll be a few rows down. We want these to be 1 high, 1 wide. These are actually going to be type 0 buttons, so the kind of buttons that don't stay latched when you press them. They're just going to be kind of press and release buttons, momentary buttons. Again, let's set the level to 2. Let's set these to call script number 3 when they're pressed. And I've got 7 kit pieces here, so we'll do column 7 and rows 1. I'm going to go ahead and run my init script by pressing F10. And if I tab back over to the display here, you can see that I've got my top row of buttons here, and this row of 7 buttons beneath it. So great, they don't do anything yet. We need to add some functionality to them in the scripts. All right, I'd like to start by adding some functionality to this bottom row of buttons. These are going to be the buttons that select the kit piece that I'm working with. And one thing I'd like for them to do is to, stay lit when I press them. Right now they just kind of flash. So it doesn't really, give me an indicator of which kit piece I'm working with. So let's add that functionality. These are the second group of buttons, and they call script number 3. So let's go ahead and work with script number 3. So the first thing I want to do is basically set all of these buttons back to their default brightness, and then I want to light up brighter the one that we pressed. So because these buttons are in a group, I can use a group operator. I can do g.gbutton.l. And I'm going to give the group. And there's an odd level and an even level. I'm just going to set them both to the same. I'm going to set them back to kind of their default brightness of 2. So that should basically make the entire group of 7 buttons dim. Now what I want to do is set the brightness of the one I pressed to something brighter. So let's use the single operator here, g.button.l. And what I want to do here is get the index of the button that I pressed. So we'll do g.button.i, and let's set its brightness to 10. Let's take a look at that. So if I pop back over to the grid display, let's go full screen here. If I press my space bar, that button is selected. You can see it light up. Let's try number 4 here. And now that button stays lit up. So that's great. That's exactly what I wanted. It gives me an indication of which kit piece I am editing. Okay, so besides having the button stay on, the other thing I want to do here when I press a button is have it look at my 16 steps of my pattern and tell me for each step whether that kit piece is set to trigger. So let's build that functionality. So continuing in script number 3 here, the first thing I want to do is store the value of the button that I pressed in here somewhere, right? I want to know whether I'm looking at the kick or the hi-hat or whatever is triggering there. So let's set that to a global variable to that value. We'll do y, and I could just do g button I, but you got to remember these buttons down on the bottom started with an ID 17. And we'd actually like to know kind of what their real value is. So let's subtract 17 off of this. And we can quickly test if that works. So we'll come back over here. You can see we've got these are different x and y values. Let me go ahead and press number 4 here. And if I look at my y value over here, now it's set to 3, which is exactly what I want. If I press this one, I'm going to expect y to turn to 0. And that is working well too. Perfect. So now that I have the index of the kit piece that I'm talking about stored in Y, let's actually go through and light up the top row of buttons to indicate whether that kit piece fires on each step. So I'm going to do another loop here from 0 to 15, because there's 16 steps in my pattern, numbered 0 through 15. And let's go ahead and call a new script, script number 4. So, in script number 4, I'm going to be iterating through my pattern steps, 0 through 15. And let's go ahead and, for each step, let's set a local variable here, j, and let's do a bget. And we want to get the value of a pattern at index I. And we want to get the bit y, which is going to be 0 through 7, whatever one we selected. So that should either give me a 0 or a 1. So let's do if j. We're going to do g.button.v for value. And the button we want to set is the one on the loop we're on, 0 through 15. We're looping 0 through 15. These buttons actually start with an ID of 1, so we're going to need to add 1 to that. So let's do +1i. That's the number of the button that we want to set its value. And if j is 1, we're going to set its value to 1. Otherwise, else, we're going to set its value to 0. Let's try that out, see if it works. So let's see, we've got kick, snare, hi-hat, and kick and hi-hat. If I pop over to the grid controller now, let's hit that one right there to show the kit piece. So looks like we've got the kick firing on step number 1 and step number 4. That looks right. If I move over to the snare and select that, the snare lit up, but it looks like it didn't clear those out yet. So let's take a look at the script, and I missed an I here in this row. So let's try it again. Kick, that looks right. Yeah, now we've got a snare on step 2. Hi-hat on step 3. Nothing on step 4. Okay, so after a moment of confusion, I think this actually is working correctly. Our pattern values are 1, 2, 4, 5, so that's kick, snare, hi-hat, kick, and hi-hat. So the kick should be on steps 1 and 4. That looks correct. The snare should only be on 2. The hi-hat should be on 3 and 4. Yeah, I think this is working exactly right. Cool. A little hard to tell without the sound. All right, so next we want to take this top row of buttons and actually give them the functionality that they set the pattern values so that we can press them and control this in real time. So in order to do that, we need to set up the script that they call. So back here, our top row looks like it calls script number 2. Let's go ahead and set up script number 2. So the first thing I want to do here is get a couple of values and store them in local variables. So for j, let's do g dot button value. We want to get the value of the button that was pressed. That value, since these are latching buttons, is either going to be 0 or 1. So we'll tell if it's on or off. That's the last button pressed. In K, I want to store the ID of the button pressed. Now, since these are starting numbered at 1 and go through 16, I actually want to subtract 1 off of that. So let's do minus G button I and 1. So that should give us a number 0 through 15, which is the number of the pattern slot that we want to modify. So we've got the value of the button that was pressed, and we've got the pattern slot that it corresponds to. Let's go ahead and set or clear those bits depending on the value. So we do an if here. If j equals 1, then let's take our pattern at k, which is going to be 0 through 15, depending on the button that we pressed. And we'll do a b set, bit set, or bitwise set. And we're going to get the value of that pattern right now. And we're going to set the bit equal to y. Why, you say? Y is what we determined over here in script number 3. When we press the button for the kit piece, we set that equal to the number of the kit piece that we pressed. So if our value is a 1, we're going to set it. If our value is a 0, we're going to clear it. So let's do an else. We're going to set the pattern at k. We're going to do a b clear on that value. Y. All right, let's test this out. I'm going to come over here to slot number 1, which is the kick. And let's clear this out, and I'm actually going to turn the volume back up here. Let's move over to the snare. Let's set the hi-hats to be on the 8th. And let's see here, I think I've got kind of a chirp sound set up on the final one here. Let's throw that in for good measure. That seems to be working great. So let's actually test this on the hardware now. Okay, so we've got the grid plugged in and fired up. Looks like everything's working. Let's give it a shot. I'm going to turn the volume back up. Let's see here. Let's go back to the hi-hat and I think this kit piece might be a clap. Let's try a clap in here. I believe this one's a tom. Seems like it's working great. All right, let's build out the last piece of this script. What I want to do is create some buttons on the bottom of my controller that will allow me to copy and paste patterns between 4 different memory locations. So let's start by creating another group of buttons. I'm doing all of these in my init script. And let's go ahead and do a g.gbx again. This is going to be group number 3. Let's just go ahead and start these at ID number 30. We got plenty of IDs here. I'm going to put these at X position 0 on the left and Y position 7, so down on the bottom row. These are going to be 1 by 1 buttons. We're going to make these type 0, which are the non-latching buttons, momentary buttons. We're going to give them a level of 2. And let's have them call our first unused script, which is 5. And I'm going to create 4 of them horizontally, 4 memory locations, and just 1 row. Let's go ahead and hit F10 to fire that init script. And if I come back here, now we can see my 4 buttons on the bottom. Perfect. So let's actually wire up the functionality of these buttons. These buttons call script 5. So from experience here, I know, when you press these 4 buttons, these are momentary buttons, so the script is actually going to get called twice. Once when you press it, and once when you release it. They'll get called with different button values of 0 and 1. I'm really only interested in the down press and not the up press. So let's put a line in here to kind of prevent the script from doing anything when when we release these buttons. So we'll do if equal g dot button value. That's going to be the value of the button we pressed, 0 or 1, on or off. If it's 0, let's just break, so we won't run anything in this script. The next thing I want to do is count the number of buttons that have been pressed, right? So these buttons are going to work by holding down the button you want to copy from, and then pressing the value, pressing and releasing the value you want to copy to. So we need to know how many buttons are pressed. If there's just 1 button pressed, all we want to do is kind of make a note of that. If there is a second button pressed, then we want to go ahead and do the copy. So let's set up our local variable here, j, and we'll do g.gbutton.c for count. And this is group ID 3, so we'll count the number of buttons that are pressed there. So if j equals 1, if just 1 button is pressed, what we want to do is store the value, store the ID of the button that was pressed there. Let's use a global variable for that. So we'll steal a, and we can set that equal to g.button_i to get the index that was pressed. What we actually want, though, we want to, that's going to give us a number like 30, 31, 32, 33. So I actually want to subtract 30 from this. So now a should contain a value 0 through 3 when we press one of these buttons. Let's try it out. So, oops, a should be 0 now. If I press this one, a should be 1. And this one, a should be 3. Perfect. All right, so if we have 1 button pressed, we're doing exactly what we want. It's when we hit the second button that we actually want to execute something. So let's do another if statement here. And basically we want to find out if our button press is not equal to 2, we just want to abort the script and do nothing else. So we'll do not equal g.gbutton.count. And we're counting, this is group 3, so let's count the button presses in group 3. If that's not equal to 2, let's go ahead and break out of the script, and we won't do anything more than store the index of the button that was pressed. If there are 2 buttons pressed, we're going to go ahead and proceed with this script. So let's go ahead and get the index of the second button that's been pressed, and we'll store that in another global. Let's take a B, and we'll do g.button I again, minus 30. Great. Now I won't actually be able to test that on the grid display here because I can't press more than 1 button at the same time. So we're just going to take it on faith for now that this works. So A should contain a number 0 through 3 of the first button that we held down. B should contain a number 0 through 3 of the second button that we pressed. So once that happens, let's go ahead and call another script in a loop. So we're going to do loop 0 through... Actually, I don't think we need to do a loop here. Let's do the loop in the next script. Let's just go ahead and call script number 6. So what I want to do here, we've got 4 memory locations. Each of them contain 16 steps. So what I want to do here is kind of determine an offset. So let's store that in a local variable j, and we'll multiply 16 times a. So that's going to be the offset for our first one. So that could be a number like 0 or 16 or 32 or 48. And let's take a local variable k, and let's set that to 16 times b. So that's going to be the offset for our destination location. Now I just want to do a loop here. We'll do loop 0 through 16. Which I guess that's 15. And what we want to do here is basically we're going to copy all the steps in one memory location to the steps in another memory location. So we'll take the pattern at the index plus the offset. So that's going to be plus k I. This is the one we're setting, the destination. Destination's in k. So we're going to get that value, or sorry, we're going to store in that value p plus ji. And the last thing I want to do here is, since we're going to be switching our patterns, let's say, for example, we're on the kick drum here, and we're looking at where the kick drum hits are in the top row. If we switch patterns, if we copy some new patterns into this location, the kick drum may move around. So what we actually want to do is kind of reset those LEDs so that we can really see what's going on here. And if you'll recall, we're actually doing that in script number 4. And script 4 is called in a loop from script 3. So we can basically, I think, just steal this line of code right here. I'll do an Alt-C to copy. And let's put that at the end of script 6. All right, we're going to need some hardware to test out this functionality, so let's take a step back. Okay, so I've got the hardware plugged in. Let's go ahead and give this a test. I'm going to turn the volume up. So let's go ahead and copy pattern 1 that's playing into location 2. Let's take pattern 1 and simplify it. Let me take a lot of these hats out of here. take that double kick out of there. Maybe take these claps out. And we'll take that chirp out too. So this is very simple. Let's copy that from pattern 1 into pattern 3. And now let's copy pattern 2 into pattern 1. And we'll copy pattern 3 back to pattern 1. Seems to be working great. All right, so quick summary of the things that we've talked about today. We looked at using the bitwise operators in the teletype, and we kind of use these to encode some trigger values, one trigger or multiple trigger values into each step. We've looked at some of the more advanced grid ops operations, like creating buttons and groups and counting the number of buttons that were pressed. I think what's really cool about this, I mean, we've only got one pattern in use, and we're actually playing an entire drum kit with it, and we've still got 3 patterns left over, and really we've got quite a bit of script space left as well. A lot of our scripts don't have too much in them, and we've even got 2 completely free scripts left, so we could do more with this. We could add voices to this or other modulations. So hope you found this useful. Until next time, take care.